underwater data center. It is no longer the impossible fantasy of, well, Mission Impossible. It is now a reality thanks to Microsoft. This week, the tech giant deployed an underwater data center off the coast of Scotland. The initiative, dubbed Project Natick, features 12 racks and 864 servers, all housed in a large tank and lowered 117 feet to the sea floor. Microsoft claims that with more than 50% of people worldwide living 120 miles off coastlines, this new wave of submersible tech could mean faster web load times and be friendlier to the environment. Here to tell us more, the program manager for Microsoft's Special Projects Research, Ben Cutler. So, Ben, first of all, what are the advantages of a data center underwater versus on land?
So, Emily, we see three potential advantages here, one of which is greater sustainability, faster deployment of new data centers to serve our customers, and then third, the ability to be more responsive to customers by being closer to them.
So, what would the benefits of an underwater data center be for me here off the coast of San Francisco?
So, as you said, if you look at the world, more than half the population is close to the coast. So as we look toward the future and we have more interactive applications, the ability to get quicker response back and forth to the data center should provide a better experience, for example, if you're playing a video game. Or on the commercial side, if you think about as we move the cloud closer to our customers, so for factories, autonomous driving vehicles, things like this, should provide a better responsiveness and better capabilities.
So talk a little bit about the pros. You have plenty of data centers above ground, right? So talk to us about the pros and cons of, an on-the-ground data center like the one you have in Cheyenne, Wyoming, and Project Natick.
So when we think about Project Natick, one of the things that we see is it's easier to cool things in the water. So over time, we've gradually reduced the amount of energy we use for cooling, but by actually putting it in the ocean, we can kind of drive that cost down almost to zero. Another thing that's really important is if you look around the world in the 21st century, we think that one of the biggest resource constraints we have is water. And if you look at the cooling systems, whether of a building or of a data center, they actually use a lot of water to cool. And so the idea of putting something in the ocean that uses seawater rather than tap water or drinking water to cool may make it possible to take data centers many places we don't go today, particularly in the developing world.
Where and when might we see this in mass production?
Well, this is a research project right now, and so what we're really trying to do is understand, does this concept work? In particular, this idea that we're going to operate a data center where it's got no human contact for several years, do the economics of that work out? And so if it does, then I think we may have a new tool that we have available to our product group to deploy in different places around the world.
What about maintenance? It would seem pretty expensive to fix a piece of faulty hardware underwater.
Absolutely. And so the idea here is what we call fail in place, which is we over-provision it. We have more servers than we think we'll need over the 5 years that we might leave it in the water. And so that even at the end of that 5 years, we can still do the full capabilities we want. There's definitely a trade-off here. But if you look at a lot of industries, over time, we go to greater and greater automation. If you go back 100 years ago, for example, many phone calls were all connected manually, whereas today we have these small buildings, they just operate and no one goes in them. Similarly, cars, if you think about when cars first came out, you had to get out of the car and by hand crank it to start the engine. They're much more automated than they used to. So this sort of thing helps reduce costs and bring greater value to our customers.
Should we be concerned about the negative environmental impact here, and how is Microsoft addressing that?
So I think that we do our research to really understand what we're doing and whether it's safe before we go to commercialization. I think one of the things that people worry about here is you're putting this in the ocean. Is it heating the ocean? Is it going to hurt the fish? We look at this very carefully, not just theoretically, but actually do real measurements. Let me give you an analogy. Imagine you're standing on a bridge and you're slowly pouring a cup of warm water into a river. If we measure the temperature where it hits the river, it's going to be relatively warm, but it rapidly mixes as it goes down the river till pretty soon it's imperceptible. The ocean is kind of similar. We have these large ocean currents. When we measure the temperature coming out of the data center, it's about 1 degree warmer than the water coming in, and then that rapidly mixes. The first phase 1 project that we did, a few feet or a few meters downstream from the vessel, the water is only a few thousandths of a degree warmer. So the effect is negligible. That's what we expect this time, but we'll be measuring it very carefully.
Now, we've heard this data center can store 5 million movies. What are you actually storing down there?
So this data center is for experimental purposes. It's used right now only internal to Microsoft, so there's no customer data there. So the early experiments that we'll be doing are to really understand, is it behaving, performing the way we expect it to? And then later we'll basically set it loose, and anybody inside Microsoft who's got some workload they want to run, they can run it there.
So, this data center, I know it's just the beginning, but it's fairly small. Less than 1,000 servers, where some data centers have 80,000 servers. Can this really scale and make a dent in the world's, the storage that is needed in today's world?
So when we set about this project, really we're very focused on the economic aspects of this. And so the particular size we chose here, which is physically about 4 times larger than the first we did, is about the size of a shipping container. And so we can ship it by truck or rail or ship using sort of the typical logistic capabilities that are out there today. So for a larger data center, you would have some multiple of these on the seabed. And so it's very scalable that way up to potentially very large data centers.